Welcome to Lagrange multipliers. This is a method of finding maxima and minima subject to constraint. So for example, if you are looking for the rectangle of largest area that lives inside an ellipse, you're maximizing area, but you're subject to the constraint of being in this ellipse. So the method of Lagrange multipliers tells us that we want to be looking for points that satisfy this system of equations. Del F equals lambda del G. Now that means the gradients are parallel. F is the function we're maximizing or minimizing. G is the constraint. The second part of this system is we set G equal to C. That's just the constraint. And so you find the points that satisfy that system, and then you evaluate F at each point to determine the max and min. So let's do an example. Find maximum minimum of F subject to the constraint G. Now there's two equals in G, and that's normal. So I'm naming G, but it's also equal to a constant 30. So that's okay that there's two equals there. So our solution, I started this out, I found del F, I found del G, and I want to set del F equal to lambda del G. That's going to give me two equations. The first one, I set the x coordinates equal. So I'll do that over here. 2xy equals lambda times 10x. The second equation will be x squared equals lambda times 4y. And the third equation is always the constraint. So 5x squared plus 2y squared equals 30. Okay, the tricky thing about Lagrange multipliers is that you typically end up solving a system that is not linear, as we have here. So my method, my go-to method, is to solve 1 and 2 for lambda. Okay, so if I solve equation 1 for lambda, I get lambda equals 1/5 y. And if I solve equation 2 for lambda, I get lambda is x squared over 4y. Now I'm going to set lambda equal to lambda. That gives me y over 5 is x squared over 4y. Cross multiply, I get 4y squared equals 5x squared. So I could solve for y squared or x squared. I'm going to solve for x squared. This implies x squared is 4/5 y squared. The reason I'm not solving all the way for x, I will eventually, but I want to use equation 3. Equation 3 has x squareds and y squareds in them. So I'm going to plug that into equation 3. Okay, and I get 5 times 4/5 y squared plus 2y squared is 30. That gives me 6y squared is 30 after I clean up. Divide both sides by 6, then take plus or minus square root. Y is plus or minus root 5. Okay, now I need x for those y's. So I go back up here to this equation that tells me x squared is 4/5 y squared. Well, if y is plus or minus root 5, then y squared is 5. So x squared is 4. All right, that tells me x is plus or minus 2. So I've got 4 solutions. They are 2 root 5, 2 negative root 5, negative 2 root 5, negative 2 negative root 5. All right, I want to plug all of those back into F. Up here, F of xy is x squared times y. The largest number will give me the max. The smallest number will give me the min. Now, f of xy squares the value of x. That means at either 2 or negative 2 for x, I'm going to get the same value. So f of plus or minus 2 root 5 is just going to be 4 root 5. F of plus or minus 2 negative root 5 will be negative 4 root 5. Okay, so that tells me that this is my max, this is my min. The max happens to happen in 2 places. I get a maximum value at both those points. That's okay. And the min again happens at 2 places at both of those points. Okay, let's do one more. Here we want to find the max and min of x squared plus y squared subject to this constraint. And again, there's 2 equals in that equation. So they all start out the same. You find del F and you find del G. And then we're going to set del F equal to lambda del G. That's going to give us 2 equations. And I'll just write those down over here. The first equation will be 2x equals lambda times 2x minus 2. The second equation will be 2y equals lambda times 2y minus 4. And the third equation will be the constraint. X squared minus 2x plus y squared minus 4y is 0. So that's the system I'm solving. So again, I'm going to solve 1 and 2 for lambda. Okay, and when I do that, equation 1, I'm going to factor out the 2's, and I'll just get x over x minus 1. And second equation, lambda is y over y minus 2. And now I'm going to set lambda equal to lambda. So x over x minus 1 is y over y minus 2. Cross multiply, xy minus 2x is xy minus y. Cancel the xy's, that tells me y is 2x. Okay, that's what I'm going to plug in to equation 3. Okay, here we go. We have x squared minus 2x plus y squared, but y is 2x, so that's plus 4x squared, and then minus 4y, y is 2x, so that's minus 8x, and that's equal to 0. So that's 5x squared minus 10x equals 0. Let's factor out a 5x. 5x times x minus 2 is 0. So x equals 0 and 2. All right, so how do we get y? We're going to go back up here. Y is 2x. So the solutions are x is 0, and then y is 2 times 0, which would be 0, and x is 2, and y would be 4. So those are the points I want to plug in to f and see what's my max and what's my min. So again, f is up here. It's x squared plus y squared. So f of 0, 0 is 0, and f of 2, 4 is 4 plus 16, that's 20. This is my min, that's a smaller number, and 20 is my max. They happen, if you're asked where do they occur, the min happens at 0, 0, and the max happens at 2, 4. Okay, and that is the end of this section.